Hey guys, I am going to do problem number 37 from section 8.2 that we didn't finish this the other day. So we had started out, I think somebody said, okay, let's let u equal cosine of 2x, and then dv would be e to the negative x dx. So we need to find du, and so if you do that, if you find the derivative of cosine, it's negative sine of 2x and then times 2. And then if we integrate this to find v, we get v equals negative e to the negative x. And I think we had started out doing that, and then we kind of got stuck somewhere along the way. But so what we're going to do is we're going to use these pieces here. So we have our v, we have our u, we have our du, and this is round 1 of integration by parts. I'm going to have to do it a couple of times. All right, so we have our u, which is cosine of 2x, and times v, which is negative e to the negative x. I'm going to rearrange that here in a minute. Then I minus v, which is negative e to the negative x, and then du, which is this negative sine of 2x times 2. This should have a dx at the end of it. Dx. Can barely fit that in there. Okay, so I'm going to just kind of hash this out a little bit. So I'm going to pull this negative out front, and the negative e to the negative x. Let's just bring that whole thing out there. Cosine of 2x. And then I have, what do I have? A triple negative, so it ends up being plus. And I'm going to take this 2 outside. I might want to leave it actually when I'm thinking about it, but I'm just going to take it out for right now. And so I pulled this negative out, this negative, and that negative. Oops. So that makes it all negative. But actually, yeah, that is a negative. E to the negative x, and then sine 2x dx. So this doesn't look very much different than what we started with, but we can get there using this method. I want to make sure that I have this all down correctly. Yeah. Okay, so now we have to use integration by parts on this piece. So let's do that with round 2. And we're going to let u equal sine of 2x. So kind of the same thing that we did over here in round 1. Du would be cosine, well, it's going to be 2 cosine of 2x. And then my dv is e to the negative x dx. And I'm going to integrate to get v. V is negative e to the negative x again. So that looks awfully familiar, but here's my v, here's my du, and here's my u. So we have negative e to the negative x, that's an e, cosine of 2x, minus 2, and then to integrate this, it's going to be, for round 2, it's going to be u v minus v, the integral of v du. All right, so we have to plug this round 2 into that piece right there. So I'm going to keep this in blue. That's from round 1. And then in here we have u, which is sine of 2x, times v. So I'm going to go negative e to the negative x sine of 2x. That's u times v, but I did v times u instead. Minus, get that out of there. Minus v, which is negative e to the negative x, and then du, which is 2 cosine of 2x dx. Again, I forgot that. Okay, so let's simplify that, all of that. I'm going to go totally new color with the simplifying here. We have negative e to the negative x cosine of 2x, And then distributing that -2, should have had a parenthesis there. If I distribute the -2, I get plus, because I have a negative times a negative, so plus 2e to the -x sine of 2x, and that -2 times this negative times that negative is all -2, and then I have left inside here because I pulled that negative out, and I'm going to take, well, hang on one second. I'm gonna take this 2 out as well. So that makes this 2 times 2, which is going to be 4. So I had this -2 times this negative and this negative, made it 3 negatives, makes it a negative. And then this 2 times that 2 that I'm going to pull outside becomes 4. And then left inside here I have e to the -x cosine of 2x dx. And if you look back at the beginning, it's exactly what we had to start with, which makes you think you're going around in circles or that you're going crazy, but you're not. We are going to, here's what you can do with that. We're going to, we know that we started out with e to the -x cosine of 2x dx, and it's equal to all of this that we have on the board. It's equal to negative e to the -x cosine of 2x. I want to make sure I didn't make any mistakes here. Plus 2 e to the -x sine of 2x. And then I have minus 4 e to the -x cosine of 2x dx. So we still haven't been able to integrate that piece. But if you look at this, what we can do is if we add this whole term over here to both sides, we get, on the left side, we get 5, and then the integral of e to the -x cosine of 2x dx. And this is only because this matched exactly to this. So we have 5 of those on one side, and that's equal to -e to the -x cosine of 2x plus 2e -x to the -x sine of 2x. And then this part adds to 0. So we could put plus 0, we don't need to. And so what we were trying to solve for is this piece right here. We're trying to figure out what that is equal to. And since we have that times 5, all we need to do is divide both sides by 5, and you have your answer. So it's e to the -x cosine of 2x dx, which is what we were trying to find, is equal to, and I can, instead of writing that whole thing divided by 5, I can also put 1/5 times -e to the -x, cosine of 2x plus 2e to the -x sine of 2x, and that is the answer. There's nothing more to integrate. So we have found our antiderivative of e to the -x cosine of 2x. If you got lost, watch the video over, pause as you're going through it, and write it down with me as you're going through this. It's going to help a lot if you follow each step. All right, that's it.